So hello everyone. This question is saying that a heavy uniform chain lies on horizontal tabletop. If the coefficient of friction between the chain and the table surface is 0.25, then the maximum fraction of the length of the chain that can hang over the edge of the table is how much? So you can see this is the diagram for this question. The chain will hang like this. Some part of the chain is on table and some part of the chain is hanging from the table. So the part of the chain, let me select the pencil first. Okay, the part of the chain which is hanging from the table, suppose that its length is x. So weight of this part of chain which is hanging from the table, suppose that its weight is w. So this weight will try to pull the chain in downward direction. Now some part of the chain is on table. Weight of this chain will apply force on table and table will apply force on the chain in upward direction normal. And due to the normal, since there is friction force between the chain and the table, there will be friction force. So this part of hanging part of chain will try to pull the chain downward, and the friction force will try to hold the chain on the table. So weight of the hanging part of the chain will apply force in downward direction to pull the chain downward, and the part of the chain which is on the table, friction force between that part of chain and the table will hold the chain together. The question is asked that, the question is asking that what is the maximum fraction of the length of the chain that can be hanged. See, this weight is trying to pull the chain on the pull the chain on ground. It drop it on ground, but this friction force of this part will try to hold the chain. More part of the chain will be hanging, more will be the weight and less will be the friction. So there is a limit how much part of the chain can be hanged. So first of all, we'll calculate what will be the weight of this chain if length is x. Total length of the chain is L. Suppose that total length of the chain is L and mass is m. So linear mass density, which is represented by lambda, lambda is linear mass density, will be equal to mass of the chain divided by length of the chain. So now mass of the hanging part of the chain will be length of the hanging part, x into linear mass density m by L. You can also solve this using unitary method. L length of chain have mass m, so one length will have m by L, so x length will have x into m by L. Now weight of the hanging part of the chain will be mass into g, so m g x divided by L. This is the length of the this is the weight of the chain hanging. This is the weight of the hanging part of the chain which will try to pull the chain in downward. Now if you make the FVD of the part of chain which is on the table, here it is facing a downward force, actually not downward. Here the force will be in this direction. Force on the hanging part is downward, so this chain will try to pull this chain in right direction. So here it will face a force in this direction which will be equal to weight of the hanging chain. So when it will try to pull this in right direction, the friction force here will try to pull it in left direction, ff, and upward direction there will be normal, and downward direction there will be a weight of the part of the chain which is on the table. And what is the part of chain which is on table? See, x part is hanging, so part of the chain which is on table will be L minus x. So this weight will be L minus x into m into g divided by L. Just like here we have mg x by L, it will be mg L minus x by L. Now friction force will be mu into n. Here we have already seen that there is no motion in the vertical direction. So this normal and this L minus x mg by L will be equal. So normal value is L minus x mg by L. So it will be equal to mg into mu into L minus x and divided by L. So this is the frictional force and this is the weight. Both should be equal. Only then chain will be stable there. See, friction force cannot be more than weight because friction force here acting is static friction force and static friction force is a reaction force. It will only act how much it is needed, but weight can be more than the friction force. That's why we are saying this is the maximum weight. We will equate the weight of the hanging part to friction force, that will be the maximum weight. If weight became more than this, now the chain will fall. So if you equate these two, mg x divided by L is equal to mg mu L minus X divided by L. L cancel, mg cancel. Now X is equal to mu L minus mu X. So let's go to next slide. Now here we'll get X is equal to mu L minus mu X. Now see, the question is asking what part of the chain is hanging. I mean, in terms of percentage, what is the maximum fraction of the length of the chain that can be hanged? Here we have said that X part is hanging. So let's divide the equation by L. So we'll get X by L is equal to mu minus mu X by L. Mu X by L will come this side. So we'll get X by L common 1. This will be plus x by L common mu is equal to mu, or we can say x by L is equal to mu by 1 plus mu. So this is the fraction of chain hanging is x by L. X is the part which is hanging and L is the total length. So x by L is the fraction of chain hanging, which is mu by 1 plus mu. So x by L, if you go to the question, the value of mu is 0.25. So it will become 0.25 divided by 1 plus 0.25 means 1.25. And if you observe it, it is exactly 1 by 5. So x by L is equal to 1 by 5, which can be written as 20%. 1 by 5 is 1 by 5 into 100 is equal to 20%. So 20% of the chain can be hanged max to max. 80% should be on table. If less than 20% part of chain is hanging, no issue. But if more than 20% of it will be hanged, the chain will fall on the ground. I hope the question is clear to all of you. Keep watching, keep learning. Thank you.